right, so looking at our one proportion z-test statistic, we're going to go through an example that kind of closely investigates this idea a little bit more. So in 2001, the Gallup poll reported that 12% of Americans were cool skeptics who reported worrying a little or not at all about global warming. In 2014, 25% of those responded to a Gallup poll classified themselves as cool skeptics. Assume that the sample size for the 2014 poll was 500. Can we conclude that the percentage of Americans who identify themselves as cool skeptics has increased since 2001? All right, so before we get started in here, just to kind of point out, we have two different proportions in our problem. We have a proportion of 12% from the year 2001, and then we have a proportion of 25% from the year 2014. Our original proportion, right, our 12% is going to be our P naught, our P sub 0. So when we're thinking about and working through our formula, this is our P naught, our P sub 0, and this 25% is our P hat. That's the newer claim that we are looking at and trying to test. So if we write out a pair of hypotheses, our null hypothesis, right, always starts with P equals, and we always use our P naught value for our null hypothesis. So P equals 0.12. Our alternative hypothesis also starts with the letter P. Right? Can we conclude that the percentage of Americans who identify themselves as cool skeptics has increased? So we're going to have a greater than, and we still use our P naught value of 0.12. So there is our pair of hypotheses. All right, now we're going to calculate our test statistic using that formula that was on the previous page, and it's also been reprinted right here. So our P naught, remember, was our 12%, and our P hat was that 25%. So we're going to do 0.25 minus 0.12 divided by the square root. Right, notice that our standard error part of this formula has the P naughts. So we're going to do 0.12 times 1 minus 0.12 divided by a sample size of 500. Right. As you're working through these, you can choose to kind of calculate these all at once. If you do some rounding, don't do too much rounding. So if we did kind of want to go through and calculate our numerator and denominator separately, this gives us 0.13 for our numerator, and then in our denominator, this is going to give us the square root of 0.002112, which then if we take the square root and divide this out, this gives us 8.95. All right, 8.95, thinking about z-scores, this should kind of tell us right away, this is a really, really large z-score, right? So that this is really, really, really far away from our mean. So z equals 8.95. Right. So this means that while the null hypothesis claims a value, or we'll say claims a proportion of 12%, the observed proportion was 8.95 standard errors higher than what the null hypothesis claims. Right. And remember, a z-score of 8.95 is ridiculously high. So our observed proportion was And we're just going to put a little note here that it was really high, really unusual, because it was so far away from our null hypothesis. So there is one example of calculating our z statistic. The biggest thing to watch out for here, make sure you get your p naughts in your right place and you get the right value in for your p hat from your sample.